Hello everybody, today we'll talk about single values in acoustics. A single value in acoustics is a value that presents the entire acoustic analysis as a single number. They're important because they combine in-depth analysis and give an output as a single number. And single values can be determined from different analysis. We'll talk about octave analysis and level versus time analysis. So let's consider an octave 1x1 spectrum. So as you can see here, the x-axis is octave 1x1 frequency bands. I've chosen from 31.5 to 16,000 because they are within the human audible range. And on the y-axis, you have the sound pressure level in dBA. So as you can see here, the octave bands, and I have put numbers on top of each band. So those numbers represents the sound pressure level of that particular band. So now what are the single values that we can find from this octave band? So the first is a minimum. So what is a minimum sound pressure level in the particular octave spectrum? Then the next is the maximum. So right now it's pretty easy to see here, but as the resolution gets higher, it might be more tedious and you need a software to do it for you as quick as possible. The third is the logarithmic addition. So you want to find the total sound pressure level by adding all the individual octave bands logarithmically. And the final is a range base, so you perform all the three single value computation, minimum, maximum, and the addition, but not for the entire range, but for a chosen range. So let's look at it in detail. So first is the logarithmic addition. So we add all the values from 31.5 to 16,000, all the sound pressure values logarithmically to find the logarithmic sum. So this is just the logarithmic addition formula. You can check more about logarithmic addition in the link in the description below. The next is the maximum, so it's looking out for the band that has a maximum sound pressure level. So this is pretty useful because we may know which band is actually contributing the most. So this is important because we know the maximum sound pressure level is from 1000 Hertz. The next is a minimum, so which band is the least important here. And this is for the entire octave spectrum from 31.5 to 16,000. But we can choose a range. Maybe I'm interested only from 250 to 4,000 Hertz or any other frequency band of interest. So in that case, we can compute the same three values such as the logarithmic addition, the maximum, and the minimum. Well, the values can change based on what the individual sound pressure levels are. For example, in this case, the logarithmic sum has not changed much because, the most dominant source, which is like 1000 Hertz to 72 dBA, is still present. Whereas the minimum is now changed. It's no longer 30, but 58. The next is a level versus time analysis. So this is a graph of sound pressure level along the y-axis versus time along the x-axis. So what we're seeing here is how sound pressure level is changing or varying with respect to time. So again, we can perform the similar single value analysis. The first is the minimum. So what is the minimum sound pressure level, when the sound pressure is varying with respect to time? What is the maximum sound pressure level? And the important thing here is we no longer are interested in logarithmic sum, but rather logarithmic average. So what is the total, sound pressure level, which is the logarithmic average of all the individual sound pressure levels averaged over a specific time frame. And finally, we have range base. So again, we can choose a particular range and compute all three. So now you have here the level versus time analysis, and we have the minimum, the maximum, and the logarithmic average. So maximum is, minimum and maximum should not vary too much because otherwise it'll mean that, levels are fluctuating very rapidly. They're not stable. And more important, we are using the logarithmic averaging and not logarithmic sum because, sound pressure level is with respect to time. So you want to average at particular time window. You don't have to, you should not add the values. This is not the right approach, but rather averaging is the right approach. If you want to learn more about logarithmic averaging, check the link in the description as well. So the next is, again, range based. So maybe, we are conducting a measurement for 10 seconds, but, the machine needs some time to stabilize. So we don't want to start exactly from 0, but we want to, give some gap. So we may choose from 2 to 8 seconds. Again, we follow the same criteria, logarithmic averaging, minimum, maximum. The values can change or stay the same, but this is just another criteria. So what are the advantages and disadvantages? Well, the advantage is that single values are combining, all the analysis in just a single number. So at the end of the day, if you want, what is the outcome of a sound pressure level or a noise in a single value, so this is the answer. But the disadvantage is that it can hide many issues because, you have no idea what the frequency content is. Maybe the single value is permissible, but there are some tonalities or there are some additional frequency-related problems which are not displayed here. So those are the advantages and disadvantages. Thank you for watching this video. I hope you enjoyed it. Have a great day.